Okay, so we're going to solve this functional equation problem where we're given a real valued function f which satisfies this equation for all real values of x, and the goal is to find the sum of f52 and f55. So we'll need to find the values of f52 and f55 at some point. But before we start to find the values of f at 52 and 55, we can actually find some values where we can immediately read off what the value of f is at those points. And looking at our equation, we could actually, if we set x squared equal to 3x plus 40, we'll see in a sec how this is going to help us to find some known values for our function f. So if we set x squared equals 3x plus 40, we rearrange this, we get x squared minus 3x minus 40 equals 0, and this factorises as x plus 5 and x minus 8 equals 0, so we get x equals negative 5, and we also get x equals 8. So for these values of x, the reason I'm doing this is so that when we have x squared and we have 3x plus 40 when x is negative 5, they're actually equal to each other. So substituting in x is negative 5 into the equation, then we have 1 minus negative 5, so 6 times f of 25 from negative 5 squared, and 3x plus 40 is also 25 when x is negative 5, and this is all equal to 40. So we've got 5 times f of 25 equals 40, so dividing through by 5 we get f of 25 is equal to 8 then. So we get our first known value of our function f. So we need to find the values of 52 and 55, but we can also find the value immediately at x equals 8, and then we'll see if these can help us along the way. So when x equals 8, we substitute this in here, so 1 minus 8 gives us negative 7, f of 8 squared gives us f of 64, and the whole point of doing this is now that 3 times 8 plus 40 is also 64, and this is equal to 40. So we've just got negative 8 times f of 64 equals 40, so dividing by negative 8, we see that f of 64 is equal to negative 5. So we've got two known values of our function f now. And to start working towards finding the values of f at 52 and 55, we could try setting this up so that we have 52 or 55 in place of our x squared here. So we'd be substituting x's, could be plus or minus the square root of 52 or plus or minus the square root of 55, but then working with the square roots could be quite fiddly. So let's try just a slightly easier approach first, would be to replace our 3x plus 40 by 52 and 55. So we'd be solving the equation here, 3x plus 40 first of all equals 52, and then also trying to find the value of x so that 3x plus 40 equals 55. So solving each of these equations, the first one is x equals 4, and the second one here is where x equals 5. So now we can clear some board space, and then we'll try substituting in x is 4 and x is 5, and then we'll get some equations involving f of 52 and f of 55. So first let's try substituting in x equals 4 into our equation and see what this gives us. So with x equals 4 we have 1 minus 4, so negative 3 times f of 4 squared is f of 16, take away f of, then 3 times 4 plus 40 gives us our 52, and this is equal to 40. So we can rearrange here, make f of 52 the subject, we get f of 52 is negative 3 f of 16 minus 40. So now if we can find the value of f of 16, this will tell us the value of f of 52. And now to get 16 in our equation, we could go with 16 as the x squared, or we could go with 16 as the 3x plus 40. So we've already done x equals 4, so let's try x equals negative 4, so that on the left-hand side we have 1 minus negative 4 gives us 5 times f of 16. So we get our f of 16, then take away f of, this is 3 times negative 4 plus 40 gives us 28. And this equals 40. So it seems like now we'd need to find the value of f of 28. So let's just quickly check what would happen if we set 3x plus 40 equal to 16 instead. So to make 3x plus 40 equal to 16, we would need x equals negative 8. So if we try x equals negative 8, 1 minus negative 8 gives us a 9 times f of, then negative 8 squared gives us 64. And remember, we actually know the value of f of 64. This is negative 5, so it seems like this is the best choice then to help solve the problem. So we've got x is negative 8, then we take away f of 3x plus 40 gives us f of 16, which is what we wanted, and this is equal to 40. So now we can rearrange here. F of 16 is equal to 9 times f of 64 minus 40. And we know that f of 64 is negative 5, so 9 times negative 5 take away 40 gives us a negative 85 is equal to f of 16 then. So we've got f of 16 is negative 85, which allows us then to find the value of f of 52. So f52 is negative 3 times negative 85, take away 40. So negative 3 times negative 85, this gives us 255, take away 40. So then we can see that f of 52 is going to be 215. So now we've found the value of f of 52, and finally we need to find the value of f of 55. So we'll go back to substituting in x equals 5 and see where that gets us now. So now if we substitute in x equals 5 to our functional equation, let's see what this gives us. So it should allow us to find f of 55 eventually. So 1 minus 5 gives us negative 4 times f of 5 squared is 25, and then here we've got f of 55, and this is all equal to 40. And we're already doing much better than earlier, because now f of 25 is known to be 8, so we've just got negative 4 times 8, so negative 32 minus f of 55 equals 40. So f of 55, when we rearrange this, is going to be negative 32, take away 40, so negative 72. And now we just need to add these two together to finish the problem. So we can conclude the answer to our problem then, f of 52 plus f of 55 is just going to be 215 take away 72, which is 143 is the final answer then.